Have you ever just stopped and watched a rocket launch and wow, it's just incredible, right? These giant machines just roaring to life, defying gravity and heading out into the blackness of space. But it brings up a really interesting question. How do they actually move up there? Where there's absolutely nothing to push against. Well, let's dive in and break down the physics, which you'll see is surprisingly simple.
Right. This is the big question. Here on Earth, moving around is something we don't even think about. Our feet push against the ground, a car's tires push against the road, a boat's propeller pushes against the water. But in the vacuum of space, what's there to push on? It seems impossible. But the answer is the key to literally all space travel. So first, let's really get a handle on why moving in space is such a totally unique problem. And to do that, we have to look at how different it is from just getting around here on our own planet.
Yeah, see, on Earth, everything we do to move involves pushing against something. The ground, the water, the air. A plane flies by pushing air backward. But space is an almost perfect vacuum. There's no road, no air, basically zero resistance. All those rules of movement that we just take for granted down here, they just completely go out the window up there.
So, what's the solution? Well, the key that unlocks this whole mystery isn't some crazy futuristic technology. Nope, it's actually a fundamental law of physics, something that was figured out centuries ago by Isaac Newton himself.
And this is it. This single sentence is the absolute bedrock of space travel. For every action, there is an equal and opposite reaction. It's a really simple idea, right? If you push on something, it pushes back on you with the exact same amount of force. It's why when you jump, you're not just pushing yourself up. You're actually pushing the entire Earth down just a tiny bit, and the Earth is pushing you back.
And that right there, that is the big aha moment. A rocket isn't pushing against the air or some invisible wall in space. It doesn't need to. All a rocket has to do is throw something, anything really, away from itself in one direction, and it'll get pushed in the other.
Okay, so how exactly does a rocket throw something with enough force to lift a massive vehicle all the way into orbit? This is where we get into the nitty-gritty of propulsion and how you actually break free from Earth's gravity.
It all comes down to the engine. Inside a rocket engine, fuel is burned, creating a ton of super hot, high-pressure gas. The engine is basically a specially shaped funnel that directs all that gas and blasts it out the back at incredible speeds. That blast of gas shooting downward, that's the action. And the equal and opposite reaction is the rocket getting shoved upward. We have a name for this pushing force. It's called thrust. And the physics behind it is pretty straightforward. The faster you can shoot that gas out the back, the more powerful the thrust you're going to get. It's why rocket engines are these incredible pieces of engineering. They're all designed to create the most powerful, highest speed exhaust possible. But just having thrust isn't quite enough. To actually break free from our planet's gravitational pull for good, a rocket has to hit a pretty mind-boggling speed. And that speed is 11.2 kilometers per second. That's called escape velocity. If you go any slower than that, gravity will eventually win and pull you right back down. And that's why rocket launches are such a huge deal. It takes an unbelievable amount of energy. A rocket is basically just a gigantic fuel tank with a tiny little capsule on top. The whole thing is designed to generate enough continuous thrust to fight gravity every single moment until it finally hits that critical speed. Okay, so we did it. We've escaped Earth. We're now floating in the vacuum of space. So what happens now? Does the engine just have to fire all the time to keep us moving? Well, once you're out of Earth's strong gravitational pull and there's no air friction, the physics of the situation changes again. The answer here is another one of Newton's famous laws, inertia. In the near-frictionless vacuum of space, an object that's moving will just keep moving at the same speed, in the same direction, pretty much forever, unless some other force acts on it. And this is a huge advantage, right? It lets spacecraft coast for millions and millions of miles without burning a single drop of fuel. Which, of course, brings us to the next obvious puzzle. If you're just coasting along in a straight line, how in the world do you steer? You don't have a rudder to push against air, and you don't have a steering wheel to turn tires on a road. And the solution, believe it or not, is, once again, Newton's third law. So, spaceships are covered in these little networks of small rocket engines called thrusters. By firing just a tiny little puff of gas in one direction, say to the left, the spacecraft gets nudged to the right. And by firing these thrusters in really precise combinations, pilots and onboard computers can rotate, turn, and fine-tune the spacecraft's position with incredible accuracy.
And that really brings it all full circle, doesn't it? Whether we're talking about the giant roaring engines at launch or the tiny little thrusters used for navigation, the principle is exactly the same. A spaceship isn't pushing against space, it's moving by pushing against its own exhaust.
And that's really the beauty of it all. This one, simple, elegant, fundamental law of physics, this idea of action and reaction, is the key that unlocked the entire cosmos for us. It's what lets us leave our home planet, visit other worlds, and send robotic probes to the farthest corners of our solar system.
You know, it's a really powerful thought when you stop and think about it. All of human space exploration, everything we've already done, and everything we still dream of doing, it all rests on this one simple principle. It kind of makes you wonder, what other fundamental laws are out there, just waiting for us to figure them out so we can unlock the next